So this lesson is about parallel lines and their angles. The first thing that we're going to talk about is the different kinds of angles that you might encounter throughout this lesson. Alright, so corresponding angles postulate. This is the thing that everything else is based off of. These are the pairs of angles that are in the exact same location at both intersections along the transversal. So as I look here, angle 1 would be in what I describe the top left position. So is angle 5. And so angles 1 and 5 correspond to one another because they're in the same place at each of the intersections. Now their relationship, because of the corresponding angles postulate, would be that angle 1 is congruent to angle 5. This would also indicate that they have the same measures. Also, angles 2 and 6 would be corresponding angles. So there's actually quite a few pairs here. I'm going to go through all of them real quick. Angles 3 and 7. And also 4 and 8 are our last pair. Alright, now by alternate interior angles theorem, by the way, these three are theorems because they're based off of this original postulate if you were doing the proofs, which we are not covering in this video. Alternate interior angles, the interior angles first of all would be 3, 4, 5, and 6. The exterior angles, which we'll see in a moment, would be 1, 2, 7, and 8. So, back to alternate interior. 3 and 6 would be considered alternate interior angles because they're from this interior group of angles between the parallel lines, and they are on different sides of the transversal, so they alternate sides. So, angles 3 and angle 6. When they are alternate interior angles, they are congruent. So, angle 3 is congruent to angle 6. Angle 4 is congruent to angle 5 by the same reasoning. And if you're trying to take a guess, you'll see 4 is an obtuse angle, 5 is an obtuse angle, so they're likely equal because the lines are parallel. If the lines aren't parallel, all this goes out the window. 3 is acute, 6 is acute, so you can kind of guess at these relationships when you see parallel lines sometimes. Alright, moving on to alternate exterior angles. Basically, what you've got going on there is you're looking at the group of angles that are 1, 2, 7, and 8. Those are your exterior angles. So alternate exterior angles would be 1 and 8. And they are congruent again. And also you'll see 2 and 7. Now, between both of these, you wouldn't want to go like angle 1 and angle 2. Those are actually simply adjacent angles. I will talk about those in a moment, but you need to go to the other parallel line when you're naming these particular pairs right here. Moving on to our last one that concerns the parallel lines, and that's going to be same side interior angles. Now, just a heads up, you might see this called consecutive interior angles, so don't get thrown off by that. The pairs would be 3 and 5. They are on the same side of the transversal, and they're in this group of interior angles that we described a little bit ago. So angle 3 and angle 5, now their relationship is not that they're equal. 3 is acute, 5 is obtuse, but they do have a relationship, and that's that they're supplementary. So the measure of angle 3 plus the measure of angle 5 would have to equal 180 degrees. You would also have 4 and 6 be another pair. The measure of angle 4 plus the measure of angle 6 would have to equal 180 degrees. Now, the last thing people always ask is there such things as same side exterior angles like 1 and 7, 2 and 8? I've seen them in textbooks. The current textbook we're using doesn't have them, but I have seen them before, so it is possible that you'll see those. Alright, moving on to adjacent angles. I didn't cover these two because in the same group because they're actually not considering the parallel lines. The adjacent angles would be, for instance, angle 1 and angle 2 or angle 1 and angle 3. So those would be examples. I'm not going to take the time to write all of them out, but there are quite a few up there. Now, vertical angles are still in play, so watch out for them. I'm going to go back up to the diagram. Angles 1 and 4 would be an example of vertical angles. So would angles 2 and 3, things like that. And those are always congruent. Angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. Now, I did not write a specific relationship for adjacent angles. Usually they're going to add to 180, but that's not always the case, so I didn't want to make that like a rule for you to have to remember. I'll talk more about that on the examples. All right, speaking of, let's go ahead and move on to those examples here. We're just going to go through a set of problems where I'm going to classify each pair, and then I'm going to determine their relationship. What's going to happen? Angle 1 and angle 3. I would say that those are vertical angles. So I'm going to write vertical. The relationship is that they're congruent. Angle 1 is congruent to angle 3. For 3 and 4, you have to ignore this line and this bottom parallel line. Those would be alternate interior. And their relationship would be that they're equal or congruent, as I'm writing here. For 2 and 8, 2 is right here. Now you have to jump over this line and consider it compared to 8. So 2 is in the top right location, 8 is in the top right location. Since they're in the same location, they are corresponding angles. So these are corresponding. So angle 2 is congruent to angle 8. 5 and 6, here's 5, here's 6. They are on the interior of these two lines right here, and they are on the same side of the transversal. So I'm going to say same side interior. Don't forget, you might see that written as consecutive interior. And that means that they're going to add to 180 degrees. So measure of angle 5 plus the measure of angle 6 is equal to 180, or I could just written supplementary angles. There is one last pair, two last pairs I'm going to talk about, 6 and 7. I'm just going to slide up a little bit here. 6 and 7 don't have one of those special relationships like we've been describing. They're simply adjacent. Now, there is the special relationship that these are a linear pair specifically, so they would be supplementary as well. And if I look at angles 1 and angle 7, so I'm going to slide this diagram up. Angle 1, angle 7, consider these two lines here and here. They are on different sides of the transversal. Also, these would be considered exterior angles for these two lines. So these are alternate exterior angles. And that means that they would be congruent as well. Now, I did not talk about a specific pair that I wanted to. Let's see here. Angle 2 and angle 3. These would be adjacent angles, but I would not be able to say that they are supplementary. So just to point that out, I would not have a specific relationship for them. Other than that, I could add them to equal this angle, but I don't know what that is. So just wanted to point that out there. Angle 2 and angle 3 are adjacent, but I don't know their specific relationship. All right, moving on to example 2. Really quick, just finding the measure of the indicated angle. So that's indicated with a question mark on this problem. I'm really quick going to make a note that these are same side interior. The arrows here indicate what lines are parallel. Forgot to mention that earlier. So when you see arrows, those are parallel lines. Because of that, I know that I can actually just add the two angles to 180 degrees. I'm going to use an X instead of a question mark. I like it better. So now I can subtract 105 from both sides and get X equal to 75 degrees. Basically, you've got one of two things that's going on here. Either the angles are going to add to 180 or they're going to be equal to one another most of the time. Occasionally you'll get something else going on, but that's a pretty reliable bet. All right, same deal for part B, finding the measure of the indicated angle. So here it is. Now I'm really quick going to identify that due to these parallel lines, they're using two arrows to indicate a different pair of parallel lines. These two angles are in the same location at each intersection, so these are actually corresponding. And if you refer to the notes at the beginning of the video, that means that they're equal. So X equals 52. And really, I probably shouldn't have been answering these with x equals. I should have just said on the first one, 75 degrees, and on the second one, 52 degrees, if I'm actually answering these correctly. And that's just simply because there was no x on the problem. It just wanted me to find the measure of the angle. All right, moving on to example 3. Don't forget, if I go a little quick for you, you can always pause and rewind. Now what's going on is I'm going to solve for x, just going to get the value for x on this problem. Now I am going to identify what kind of angles these are due to the parallel lines. These are on different sides of the transversal. Also, they are in the group of what I would describe as exterior angles. So these are alternate exterior angles. And if you refer to the notes at the beginning of the lesson, you would know that that means they are going to be equal. 7x minus 9 would equal 96. And what I can now do is just solve this equation. I'm going to add 9 to both sides. So that 7x will equal 105. And then I'm going to divide by 7. And so x equals, let's see here, 105 divided by 7. I feel like I should have probably calculated this ahead of time, but whatever, I'm doing it now. So 35, 15. All right, x equals 15. That's slightly embarrassing that I didn't know that as a math teacher, but do not judge me. All right, now moving on to example 4. I could always edit out those mistakes that I have, but I feel like that just makes me a little bit more human. All right. This is a little different. We are not just solely after the value of x. In the instructions, it says find the measure of the angle in blue. And if it doesn't show up too well in the video, this angle is what I wrote in blue, 21x plus 4. The other one's written in black. Now, there is a different way for them to present the lines as being parallel. They could name the lines with lowercase letters and then use this symbol that means parallel. So I did want to point that out in this example. All right, really quick. These two angles are what's called same side interior angles or consecutive interior. I'm going to keep on saying that. And what's going to happen is I could actually add those to 180 degrees. So the 25x minus 8 plus the 21x plus 4 equals 180 degrees. Now, this is actually going to rely on us combining like terms at this point. 25x plus 21x is 46x. Negative 8 plus 4 is minus 4. I'm going to add the 4 to both sides. So 46x equals 184. Then I'm going to divide by 46. So x is equal to, that would be 4. Don't ask me why I knew that one really quick and I didn't know 105 divided by 7. All right, now this is not my final answer. The last thing to do is find the measure of the angle in blue. So I'm going to plug that back in. 21 times 4 for x, and then add 4. So I brought this equation over here, use substitution property. 21 times 4 is 84, and I still have the plus 4. 84 plus 4 is 88 degrees. For that angle in blue. That's my final answer, and that wraps my video. Thank y'all very much.